Hello, and welcome to Solving Radical Equations. All right, so in order to solve radical equations, first we're going to isolate a radical on one side of the equation, a being the indefinite article. Look at me getting all fancy here. There might be more than one. All right, so choose one. It doesn't matter which one. Choose one. Isolate it on one side of the radical. Square both sides, and I'm going to put this in quotes because sometimes we'll need to cube both sides. It depends on what the index of the radical is. But square both sides of the equation to eliminate the radical. We'll isolate any remaining radicals if needed and square again. So this is shampoo instructions, right? It's lather, rinse, repeat. That's all it is. Isolate, square, repeat. Lather, rinse, repeat. Solve the remaining equation. When you no longer have square roots in it, solve it. Check your remaining answer in the original. You may have extraneous or extra answers, all right? Just like we did with rational equations, the process we use to solve sometimes creates extra answers. Here we go. Okay, so for number one, square root of a equals 12. Okay, I'm going to isolate a radical on one side of the equation. It's already there. Because it's a square root, I'm going to square both sides. When I square, I just take it as it is. A equals 144, and we're done. Don't overcomplicate it. Don't make it harder than it needs to be. Don't make it harder than it already is. I'll give you hard enough material another time. Isolate the radical. If the square root of x, the opposite is square. Square both sides. The square root squared is x. 5 squared is 25. Notice there's no plus or minus here. It's only when we take the square root that we put the plus and minus. When we're doing the opposite of the root, when we're squaring it, we do not need the plus and minus. All right, so when the radical's isolated, that just seems too easy, right? You're all thinking, come on, give me something harder, Tuesday. Subtract 8 from both sides. We want to isolate our radical. The square root of m minus 3 equals 4. Now that the radical is isolated, we can square both sides. I'm going to take this up over here. For some reason, I don't want to scroll down. I don't know. M minus 3 equals 16. Let's add 3 to both sides. We'll get m equals 19. I almost wrote just 9. Let's get a 19 in there. Okay, now, m equals 19. Let's check it out. Let's turn on our calculator here. And let's do the square root of 19 minus 3. Come out of the radical and add 8. Now when I hit enter, I should get a 12. Let's see. There we go. So we know our answer is correct. It's the best thing about math is you could almost always check your answer. With history, man, you need a phone booth. Okay, let's isolate the radical. So we're going to add 3. So we'll call this isolate. And after we isolate the radical and draw a line through the important stuff there, now we're going to square both sides. We get x plus 2 equals 9. We can solve that. Let's subtract 2 from both sides. X equals 7. I'm pretty sure this answer is right, but let's check it. What do we have? 7 plus 2 minus 3. The square root of 7 plus 2, that's the square root of 9. Minus 3, the square root of 9 is 3. 3 minus 3 is 0. Awesome, it works out. So you can check by hand, preferably not that sloppy, or you could check on your calculator. Okay, so this is easy, right? Let's put some word problems into it and then see how you feel, right? That's how we always do. What do? We teach a concept, and then we do some simple problems, and then we throw word problems at you. And then we're like, ha ha ha. And then I'm going to do some more complicated problems after the word problems. Here we go. The period of a simple pendulum, think of a grandfather clock, right? And the pendulum that swings back and forth back and forth, back and forth. All right. The period of a simple pendulum for a small amplitude is given by the function t of L equals 2 pi the square root of the quotient L over 32, where t of L is the period in seconds and L is the length in feet. Okay, so a couple of things. First of all, it's good to know that the t, the time, is in seconds, the L is in feet. That's going to help us a little bit with what we have. It says find the period. So find t when L is 1 foot. Okay, I could do that. That's t of 1 equals 2 pi square root of 1 over 32. And how am I going to solve this? I'm going to use my calculator. And this is what it'll look like on my calculator. It might look like like this on some of yours. 2 pi square root of 1 divided by 32. And we will get 1.110720735, to which we will approximate that at 1.11 seconds. My little dog Stella just wanted to be heard. Handled that hopefully. There's, I don't know, wind changed direction or something. That's all it takes for my dogs to bark. Okay, second question here. How long tells me I'm going to find a length. Does the pendulum need to be, if we want the period to be 2.5 seconds? So breaking down what the question is, the units are super helpful. How long? Oh, long is a length, right? The period is 2.5 seconds. Oh, I'm given a time. I'm given this output. So we could set it up as 2.5 equals 2 pi square root of L over 32. Make sure that 32 is under the radical as well. So there's two types of questions. One question is, evaluate. The other one is to solve. Use the units to know which one is which. Okay, now we need to isolate. Isolate the radical. So let's divide both sides by 2 pi. So I have 2.5 divided by 2 pi equals the square root of L over 32. Fantastic, I isolated. Second step is to square. Notice I'm not reaching for my calculator yet. I'm not reaching for my calculator on this because I know I'm going to have to put this all into the calculator later. I'm going to do it all at the same time. So after I square both sides, I'll have 2.5 over 2 pi all squared equals L over 32. To get the L by itself, we'll multiply both sides by 32. And we end up with, let's take this up over here, 32 times 2.5 over 2 pi squared equals L. Now, if you asked a clockmaker to make a pendulum for your grandfather clock of exactly this length, they would look at you like you were crazy. So let's figure out what that is on the calculator. So 32 parentheses 2.5 divided by, now here's where it gets a little sketchy. This is where you have to be smarter than your calculator. I'm going to put parentheses around that entire denominator, or else the calculator doesn't know. I'm going to actually go ahead and do that. Calculator doesn't know the 2 and the pi are both down there unless you tell it, hey, consider these two together. Multiply 2 and pi, throw those in the denominator. Now I have to close the parentheses on the 2 pi, close the parentheses around the whole fraction, and then I will square it. And it looks like our length should be 5.0 Yeah, my hand's not participating with me as I'm recording this. 066059182. So we're going to say 5.07 feet. Always a good idea to put units. Make sure you know what it is that you're solving for and what units go with it. All right, that's the first one. That's only page 1. I'm not going to let this one get too out of hand, I promise. Okay, at sea level, the speed of sound through air can be calculated by using the following formula. The formula is C equals 340.3 times the square root of the quotient that has T plus 273.15 in the numerator and 288.15 in the denominator. C is the speed of sound in meters per second. E equals mc squared, same C. And T is the temperature in degrees Celsius. Temperature in degrees Celsius. Okay, so let's get this here. C is speed in meters per second. And T is temperature in degrees Celsius. So what do we want here? Find the speed of sound. So find C when the temperature is 25. All right, we want to interpret the words into what this means mathematically. Find C. Fantastic. I could just plug in and find my answer. T is 25, so I'll do 25 plus 273.15 all over 288.15. Now, this is fantastic, but in order to put it in my calculator, I'm going to put parentheses around my numerator. Anytime something's happening in a numerator or denominator, as we saw in the last example, we'll want to use parentheses on our calculator. So let's see what this one will look like. So we have 340.3. Oh, I did not mean to square that. Hit the wrong button. Square root. And then the numerator, 25 plus 273.15. Oh, that clicky gets it to me. So let's move back one. There we go. Divide it by 288.15. Now I'm out of the square root. Some of you will need to close a parenthesis after the whole square root thing too. 346.15 meters per second. The speed of sound when the temperature is 25 degrees Celsius. All right. Now, what if I want to find the temperature when the speed of sound is 350? Well, now I'm doing the opposite, right? Now I'm trying to solve, and I just noticed I will absolutely need more room. Let's solve this. Now, 350 is our C value. We have the rest of this entire equation, 340.3, let's not forget that, 0.3, square root of T plus 273.15. Oh, this is so sloppy, I can't do this to you guys. How are you going to follow that? Oh, that's ridiculous. All right, let's do this better. 350 is our speed of sound. Our C in general is equal to 340.3 times the square root of T plus 273.15 all over 288.15. Okay, now we want to isolate. To isolate the radical, we're going to divide both sides by 340.3. And I'm going to leave it. 350 divided by 340.3 equals this radical. Next step, we square. And it looks like I'm going to want to take some more space, so I'm just going to throw this on the next page. When we square both sides, on the left, we'll have 350 divided by 340.3. Square it all. On the right-hand side, we'll have t plus 273.15, all divided by 288.15. And finally, we're going to solve. In order to solve, first thing we do is get rid of that denominator. Nobody really likes denominators. Not really even mathematicians, but we'll lie to you and tell you we do just to try to get you to like what we do. Not because we need approval, just because we like it so much, we like to share it with others. 288.15 times 350 over 340.3 squared equals t plus 273.15. Finally, let's subtract this 273.15 from both sides. And I'm going to take this answer up over here where I'll have a little bit more room. So I'll have 288.15 times 350 divided by 340.3 all squared. And then I'm going to subtract 273.15, and this should give me my t. Now I could have divided 350 by 340.3 right here at the start, but then I'm writing that decimal all these different times, and then by the time I've written it that many times, I've totally shortened it, right? I've taken it down to 1, maybe 2 decimal places, 3 if I'm feeling adventurous. My answer is going to be wrong in the calculator. If I round here and then I square it, I'm like, oh, that's too many decimals, I'm going to round. And then I multiply it, and oh, I'm going to round. Rounding too soon is what makes answers off. So I wait until the very last step, put it all in the calculator at once, exactly as it's written here. What do we have? 288.15 parentheses, 350 divided by 340.3, close the parentheses, squared, minus 273.15, and we get a temperature of 31.7 degrees Celsius. All right. Let's see if that makes sense. A temperature of 25 degrees Celsius, speed of sound 346.15. As the temperature rose, speed of sound rose. All right, seems reasonable, right? And cold, speed of sound probably travels pretty fast. I don't know. Okay, now this is where a normal video would end, because it's almost 20 minutes already. But I'm going to keep going. I'm going to do just some examples of solving without all the words messing us up. A little note for my students: you should absolutely be prepared for one of those word problems on your final exam. Okay. So to solve the following, first we need to isolate. All right, they're both isolated, it doesn't matter. So let's square. When we square both sides, the square cancels out the square root. We'll have a plus 7 equals 3a plus 1. And now we just solve. Just solve like we normally would. Let's take the 3a to the other side. This will leave us with a negative 2a. And at the same time, let's take that negative 7, or take that 7 to the other side by subtracting it. We will end up with a negative 2a equals a negative 6. And if negative 2a equals negative 6, it must be that a equals 3. And we can check. What's a plus 7? What's 3 plus 7? 10. All right. 3 times 3 is 9. 9 plus 1 is 10. Square root of 10 equals the square root of 10, and we've checked our answer. Wasn't so bad. That one took about a minute. All right. Some of these can be that straightforward. However, not all of them. Okay, so we have isolated. Isolate's done. So now we're going to square both sides. And when I square the left, no big deal. When I square the right, it's a big deal. On the left, we get 4x plus 3. On the right, we get 7 minus the square root of 4x minus 5 multiplied by itself. So we don't want to just square the 7, square the radical, be done. Remember, if something is squared, it's multiplied by itself. So we actually have to FOIL here. Square and then simplify. So 7 times 7 is 49. Minus 7, square root of 4x minus 5, minus another 7, square roots of 4x minus 5, plus, minus times a minus. Square root times itself, that's going to give us 4x minus 5. So I'm going to add everything I can together on the right-hand side. I'm going to start with minus 14 square root of 4x minus 5. I have a 4x. I have a negative 5 and a positive 49, so I'm going to call that plus 44. But now, remember, lather, rinse, repeat. We have to isolate again. Because there's still a radical in our equation, now we have to isolate. So we're subtracting the 4x, subtracting the 44. Subtract the 4x, subtract the 44. 4x's cancel out. Negative 41 equals a negative 14 square root of 4x minus 5. I'm going to take this up to the other column over here. To truly isolate, I should take that negative 41, divide it by a negative 14 to get equal to 4x minus 5. And just, even though my calculator just turned off, I want to check it just to see. 41 divided by 14, fingers crossed. No, it's nothing good. So I'm going to leave it. The only thing I'm going to change is, since it's a negative divided by a negative, I'm going to make it positive. So again, we square. We'll square both sides. And after we square both sides, we will have 41 over 14 squared equals 4x minus 5. We can add 5 to both sides. And then we can, I'm going to have to push this number 3 also. Let me see. Come back, make sure I can do it. Fantastic. And then we'll divide by 4x, right? It just keeps going. We're not going to divide by 4x. We're just going to divide by 4 because we want x to be by itself. 41 over 14 squared plus 5 divided all by 4. Here we go. So I'm going to do 41 divided by 14 squared, add 5, and then divide it by 4. And if I hit enter each time, I don't have to confuse myself. I don't have to worry about parentheses. When am I doing them correctly? How many do I need? Where do I need them? And all of that. And we could check this. We could check this in a number of ways. I'm going to check it by graphing. 4x plus 3 on the left. So that's my y1. On the right, 7 minus the square root of 4x minus 5. And I'm going to graph these two. Clearly, we see an intersection. So let's calculate that. We'll use the blue button. 5 is the intersection. First curve, yes. Second curve, yes. And I just want to show you real quick. See up here in the top of the window? That's how some of you have to input it. This is the regular calculator format. The pretty print that shows like this typed out version here, on my calculator is an upgrade. So not all the calculators necessarily have it. Yes, that is my second curve. And sure, that's my guess. 3.394, whatever we had before, that's exactly what the answer is. So we're doing well. You're doing fantastic. I'm just going to do some more examples. They're the exact same thing, exact same idea. So hold on. So we have isolate, which means we need to square. So I will square the left side. And I will square the right hand side. When we square the left side, we get 2x plus 7. When we square the left side, kind of remind myself here that this is multiplied by itself. Right? So I'm going to take out this parenthesis. So instead of squaring it, sometimes that's exactly what I'll do. I'll say instead of squaring, I'm going to multiply it by itself. Now 3 times 3 is 9. I'll have a minus 3 square root and another minus 3 square root. So minus 6 square root of x minus 5. Two negatives multiply to be a positive. The square root multiplied by itself is x minus 5. Let's throw in a little simplification step. 2x plus 7 equals 4 plus x minus 6 square root of x minus 5. Let's then isolate. And again, I don't leave myself enough room. So if we isolate our radical, we'll subtract 4, we'll subtract x. We have 2x plus 3 equals a negative 6, x minus 5. I'm going to show you a little trick. When we square both sides, that negative 6, I don't actually have to divide by it. When I square that right-hand side, and you see now I have to remember it's 2x plus 3. What? Don't let me get away with that. 2x minus x, that's only 1x. Don't let me lie to you. That's x plus 3 times x plus 3. On the right-hand side, minus 6 square root of x minus 5 times minus 6 square root of x minus 5. Let's multiply them both out. Okay, and this is why we get extra answers or extraneous answers, is because we're not actually multiplying by the same thing on both sides. Now we're claiming these are equal, and if these are equal, we could find the answer. So assuming these are equal, we're multiplying by equal things on the same side. So it's a little funky here and there, and I had some extra answers pop up every once in a while. When I multiply on the left, I'll have x squared plus 6x plus 9. On the right, negative 6 times negative 6 is 36, but all of this is being multiplied together. So when we multiply those square roots, square root of x minus 5 times the square root of x minus 5, we'll put that x minus 5 in parentheses because the 6's are multiplied. It's all multiplied together. And now, finally, we can solve. Anytime we have a quadratic, we'll get our quadratic equal to 0. So let's distribute on the right-hand side. Ooh, 36 times 5. 180. So I'm going to subtract 36x and add 180 to both sides. And I'll end up with x squared minus 30x plus 189 equals 0. That's my dog. That's my boy Nike. He just whines for no reason. Just kind of some moans here and there. Gotta find him. He's the most vocal dog we have, and we love him terribly. Terribly, I tell you. All right, so I multiply to get a positive 189. It means the same sign. The 30 is negative, so they're both negative. And I ask myself, what multiplies to get 189? 189. Well, of course, it's divisible by 2. Not 2, 1. It's divisible by 9. 189 is divisible by 9. So let's see what happens here. 21. Okay, so I'm sorry. I'm a good guesser. Now, as I was looking at 189, I was like, what do I try? I tried 1. Yeah, I know that works. It's not an even number. It's not 2. I could try 3. I could try 4. I just happened to guess really well, and I got the answer on my first try, and I'm sorry. I wanted to show the struggle, but it didn't happen. X minus 9 equals 0. X minus 21 equals 0. X equals 9. X equals 21. I'm not circling yet because I want to put these back in. And I'm going to let my calculator do the work on this because I did a lot of work by hand, and I want to make sure that this works out for reals. All right, for certain. So I'm going to have 2 times 9. Oh, let's do this a different way. I'm going to do 9 store for X. My left-hand side, the square root of 2x plus 7 gives me 5. The right-hand side, 3 minus the square root of x minus 5 gives me 1. Oh, bummer. So 9 does not work. Let's try 21. Store that for x. And then I can type in the square root of 2x plus 7. And I'll get 7. 3 minus the square root of x minus 5. And I get negative 1. And that makes me wonder where I messed up. Oh my goodness. Hold on. And after we check and we see that neither of them work out, we're asking ourselves, well, what did we do wrong? So honestly, I just paused the video and I checked every single step. And then I thought, okay, this is a learning moment, right? We're thinking 21 doesn't work either. What the heck? Let's see if we're right. We could enter our graph, 2x plus 7 and 3 minus x square root of x minus 5. When we graph them, look at that. They never intersect. And if they never intersect, it is true that there is no solution. Yep. Sometimes we'll do a whole bunch of work, and the answer is there isn't one. And that hurts me as much as it hurts you. Absolutely. Okay, now I encourage you to try this one on your own. Remember, it's always easier when you're watching me or anyone else do the work. Yeah, Nike's ready for me to be done. He wants to go play. We're going to isolate both sides, and then we're going to square both sides. So when we square both sides, on the left, it's easy. It's 4x plus 4. On the right, remember, that's 4 plus square root of 3x minus 2 multiplied by 4 plus square root of 3x minus 2. And we simplify. So 4x plus 4, right? The isolated one's always the easy one. 4 times 4 is 16. 4 times this square root and 4 times the exact same square root makes plus 8 square root of 3x minus 2. And then plus times plus is plus. Square root times square root just gives you the radicand, the thing on the inside. 4x plus 4 equals, now 16 and minus 2 is 14. Plus 3x, x plus 8 square root of 3x minus 2. Let's subtract 14 from both sides. Let's subtract 3x from both sides. We'll end up with x minus 10 equals 8 times the square root of 3x minus 2. Again, isolate. I should probably put that step up here. Isolated. There we go. Isolated. Check mark. So now we're going to square. When we square the x minus 10, remember that's x minus 10 multiplied by itself. When we square on the right-hand side, 8 squared is 64. The square root squared is, in parentheses, 3x minus 2. All right, let's take this up. I don't want to throw on a 6th page here. X squared minus 20x plus 100 equals 64 times 3, 192x minus 128. Whoo. We'll take those to the other side. And we have x squared minus 212x plus 228 equals 0. You ready to factor? Yeah, me neither. Remember, we can also solve by the quadratic formula. B squared, that's 212 squared minus 4 times 1 times 288 all over 2 times 1. All right, so let's take care of that radicand. So we have, in parentheses, negative 212 squared minus 4 times, and I'm going to put it in my calculator exactly as I have it on my quote paper, my electronic paper. 43,792 is underneath the radical. Cross whatever you can cross. Well, isn't that just a bummer? The square root of 43,792 all over 2. And I'd really like to be done with this problem. So let's do 212 plus the square root of 43,792. Divide that by 2. We'll have 210.6. And then we'll come back. I'm going to do second entry. I'm going to change this addition to a subtraction. And then divide that answer by 2. And we'll get 1.4. We'll go to one decimal place for each of those. Those are answers I absolutely should check in here, but I'll be honest with you, I'm not feeling it. I don't want to, and so I'm not going to. But you can check the graphs. You can make sure it works. It's already a 40-minute video. Your patience and your persistence, much appreciated. Thank you so much for listening. Have a fabulous day.